Students, how are you? This is Amrish Kumar speaking. I'm an alumnus of IIT Kanpur, a B.Tech Chemical Engineering graduate from IIT Kanpur, and I'm into teaching physics. So the topic which we are going to discuss today is oscillation. Okay, the properties. Now I read what the properties of oscillation. Okay, it is a periodic motion. Another correct property is that motion could be to and fro or back and forth. It could be back and forth or to and fro. Okay. And third property is path is repeating. Path is repeating. So these are three important properties of oscillation. Motion is periodic. Motion could be back. Motion is no, it's not could be. Motion is back and forth, or motion could be back and forth or to and fro, and path is repeating. Okay, path is repeating. The three characteristics of motion, oscillation. Now we are going to discuss some other characteristics of oscillation or harmonic motion. Yeah. Other characteristics of oscillatory motion. Okay, first, that it has an amplitude. It has amplitude. What is the meaning of amplitude? Amplitude is the maximum displacement of the oscillating body from mean position. Amplitude, it is maximum displacement. It is maximum displacement of the oscillating body from the mean position. From the mean position. And mean position, another definition of it, another term is a position or point of equilibrium. Mean position or point of equilibrium. Point of So this is the definition of amplitude. Maximum displacement of the oscillating body from the mean position or point of equilibrium. Okay, this is amplitude. Another characteristic that we are going to discuss today is time period. Okay, time period. We are going to another term that we are going to discuss is time period. Time period. How we define time period? It is the time interval between two identical positions. Time period. It is the time interval between two identical positions. of the oscillating positions of the it is the time interval between two identical positions of the oscillating body passing through the points in the same direction. Body passing through the point in the same direction, passing through the points in the same direction. Okay, so this is time period. This is the definition in time period. Time interval between two identical positions of the oscillating body passing through the points in the same direction. Now I'll just show it through diagram. It will be easier to understand, comprehend. I'll draw the diagram. First you just note it down. Okay, time period. It is a time interval between two identical positions of the oscillating body passing through the points in the same direction. So what it means, let us understand through diagram. What it means, let us understand through diagram what it means. Okay, suppose right, this position and this position motion is same, so this is time period. Okay, this position and this position, motion is same, so this is time period. Again, from this position to this position. So these are two identical positions. These two are identical positions. These two are identical position, and these two are identical position. So that interval is called time period. Okay. To diagram it is easier to understand that it is the time interval between two identical positions of the oscillating body. Okay. So this is diagram, time interval between two identical positions. Okay. Now, what is the unit of time period? It is second. This unit of time period is second. Okay. SI the unit of time period is second. Okay. Now with another important term which we are going to discuss is frequency. What is the frequency of oscillation? Okay. What is the frequency of oscillation? Okay. What is the frequency of oscillation when the body is in oscillatory motion? What is the motion? What is the frequency of the oscillation? Definition is that it is the number of complete cycles of the oscillating body in 1 second. Frequency is number of complete cycles number of complete cycles the oscillating body undergoes in 1 cycles. The oscillatory body second. So this is the definition of frequency. Number of complete cycles the oscillatory body undergoes in 1 second. So frequency is inverse of time period. Okay, just write it down. Number of complete cycles the oscillatory body undergoes in 1 second. Okay. Frequency equals to 1 upon time period. This is the definition. Frequency is reciprocal of time period. F equals to 1. So SI unit of time period is second. So unit of what will be 1 upon second, or second 1 upon second. Okay, this is the unit of SI unit of frequency. It is per second. Another unit is that is commonly used is hertz. Unit of frequency is hertz. Unit of frequency is hertz. Okay, so we have discussed 3 important characteristics of accelerating motion. They are amplitude, time period, and frequency. There are these three properties or characteristics which we could say they define accelerating motion. Okay, now we are going to up till now we have been discussing accelerating motion, or you could say harmonic. Now we are going to discuss simple harmonic motion. How simple harmonic motion is different from accelerating motion, that we are going to discuss. Okay, now we are going to discuss simple harmonic motion. Simple harmonic motion is not same as harmonic motion. Simple harmonic motion. So how we define simple harmonic motion is that acceleration of the oscillating body is directly proportional to negative of displacement. Okay, so definition is that acceleration of the oscillating body or particle body or party in simple harmonic motion is directly proportional to negative of displacement it is proportional to negative of displacement. Acceleration of the body in simple harmonic motion is directly proportional to negative of displacement from a point. From a fixed point. Okay, what we call this fixed point is mean position or point of equilibrium. Fixed point, we can say this fixed point as mean position. Okay, this is mean position or position of point of equilibrium. Okay, point of equilibrium. So this is basically the definition of simple harmonic motion. Acceleration is directly proportional to negative of displacement from the fixed point, and that fixed point could be mean position or point of equilibrium. So mathematically, how we define A is directly proportional to negative of acceleration is directly proportional to negative of displacement. Right? So what is the meaning of negative displacement? Is that the acceleration is always the direction of acceleration is always towards the mean point. Suppose first just then I'll draw a better diagram. You first write this thing. Acceleration of the body is directly proportional to negative of displacement from fixed point. That is called mean position or point of equilibrium. Okay, so this is mathematical definition. A is directly proportional to minus x. So what is the direction of acceleration? It is always towards the mean point, opposite to displacement. What is the direction of acceleration? Direction of acceleration what is the direction of acceleration? It is always towards the mean point. Direction of acceleration always towards the it is always towards the mean point. Direction of acceleration is always towards the mean point, always opposite to the direction of displacement. Okay, it is always towards the mean point. This is the direction of acceleration, always towards the mean point. Now later we'll understand what is the meaning of A is directly proportional to x. I'll be discussing this thing later when I will discuss acceleration in detail. So I'll just explain how acceleration is directly proportional to negative of displacement and what is that proportionality constant. Okay. Now, simple harmonic motion is okay. Now we discuss what is the meaning displacement. Okay. Now I'm going to discuss what is displacement in simple harmonic motion. Okay. It is a shift in the position of an oscillating body from mean position. Shift in the direction. Shift in the position. This shift in the position of the oscillating body or body in simple harmonic motion from shift in the position of the body in SHM simple harmonic motion from mean position. It is shift in the position. It is shift. So this is basically the definition of displacement. It is shift in the position of the body in simple harmonic motion from mean position. Mathematically, how we represent it? X equals to A sine omega t plus phi. So this is x equals to a sine omega t plus 5. Okay. What is a? We discussed a is amplitude. Okay. A is amplitude. What is omega? Is angular frequency. Omega equals to angular. It is angular frequency. Omega is angular frequency. Also, it is also written mathematically as 2 pi upon t time period. Okay. A equals to amplitude. Omega is angular frequency. 2 pi upon t, and t is time period. Okay. And f phi is some phase constant. And phi is some phase constant. So this is the definition of a displacement of a body, in simple harmonic motion. Okay, this is, just write it. Shift in the position of the body in SHM from mean position. X equals to a sin omega t plus phi is amplitude. Omega is angular frequency 2 pi upon t, and phi is some phase constant. Okay. Next topic that I'm going to discuss is velocity. Next topic which I'm going to discuss is velocity. Okay, the next topic that I'm going to discuss is velocity. Velocity. What is velocity? How we define? So we know the conventional definition of velocity. Velocity equals to dx upon dt. Okay, velocity equals to dx upon dt. And what is x here? What is x equals to? We just discussed x equals to a sine omega t plus 5. X, we just discussed it. X equals to a sine omega t plus 5. And this is, and velocity equals to dx upon dt. Okay. So we differentiate it with respect to time. V equals to a sine omega t plus 5. So what we get here is a omega cos omega t plus 5. This is what we get when you differentiate it. V equals to d upon dt, a sine omega t plus 5 is equals to e omega cos omega t plus 5 when we differentiate velocity using first principle of calculus. Okay. So this is what we get. Now we take x equals to a sine omega t plus 5 and square it. What we get is x square equals to b square. Squaring x equals to a sine omega t plus 5. What we get here is x square equals to a square sine square. We have squared x equals to a sine omega t plus 5. We have squared. So what we have is now x square equals to a square sine square omega t plus 5. Okay. Now we see that we use trigonometric identity that we studied in our junior classes. X equals to that sine squared theta plus cos squared theta equals to 1. Sine squared theta plus cos squared theta equals to 1. Okay. So what is sine squared theta then? Sine squared theta equals to 1 minus cos squared theta. Sine squared theta equals to 1 minus cos squared theta. From here we get this thing. Sine squared theta equals to 1 minus cos squared theta. Now we substitute this thing for sine squared theta. Here we substitute, making this and using this principle. So what we have is x square equals to a square. Okay, 1 minus cos square omega t plus phi. X equals to a sin omega t plus phi. So x square equals to a square sin square omega t plus phi. So x square equals to a square minus cos square omega t plus phi, using this principle. Okay, and this, or you could say using this principle, sin square theta equals to 1 minus cos square theta. Okay, so now we make some rearrangements. Okay, so what we have is x square equals to x square. Now we make rearrangements using, so we have cos square omega t plus phi equals to a square minus x square. So making rearrangements, x square equals to a square 1 minus cos square omega t plus phi. From there we get this equation by making some rearrangement. A square cos square omega t plus phi equals to a square minus x square. A square cos square omega t plus phi equals to a square minus phi square. We get this thing from this equation. Okay. X square equals to a square 1 minus cos square omega t plus phi. From there we get this. Now here we square. Now we are going to take square root. Okay. That's what happens. A so this is what we get by squaring. If you square this thing, a square cos square omega t plus theta equals to a square minus x square. Square root, we have taken square root. So what we get is a cos omega t phi equals to a square minus x square root under. Okay. So let me write this thing. Okay. Square root equals to a cos omega t plus phi equals to yes. So we use this. Now we'll use this thing. A cos omega t plus phi equals to a square minus x square root under. From this we square root, so we go from here to here. Okay, a cos omega t plus phi equals to now we come back to this equation again. Okay, we come back to b equals to d upon dt a sin omega t plus phi equals to a omega cos omega t plus phi. Okay, so what we can write for a omega cos omega t plus phi equals to v equals to omega a cos omega t plus phi. Okay, b equals to we have taken this side is b equals to omega a cos omega t plus phi. Okay, so what is this thing? This is a cos omega t plus phi. So a cos omega t plus phi equals to a square minus x square root under a square minus x square root under. This is what we mean as what we understand is velocity. Velocity equals to velocity equals to omega root under a square minus x square. This is the general definition of velocity of a particle of a body in simple harmonic motion. V equals to omega root under a square minus x square. Okay, let's go through these mathematical steps. V equals to omega a cos omega t plus phi equals to omega a square. Now we will discuss some special cases, some conditions, some special cases of this equation. Okay, just write it down, or you can take. Okay. So our general definition of velocity is velocity equals to omega a square minus x square. Okay, a is amplitude, x equals to displacement. We discussed it earlier. Omega is the angular frequency. Now, when x equals to 0, when x equals to 0 or at the mean position. When x, what happens at when x goes to 0 at the mean position? What we get is that v equals to v max equals to omega into a. X becomes 0. Okay, so we have maximum velocity equals to omega equals to omega multiplied by amplitude, omega angular frequency multiplied by amplitude. This is maximum velocity at mean position. Maximum velocity at mean. This is at mean position. V equals to v max omega a at mean position. Okay, so we have maximum velocity at mean position. Okay, the maximum velocity at mean position. So of course, by analogy or corollary, you could say what will be the velocity at the extreme point? Okay, velocity at extreme positions, which implies the point at which the motion returns. This is the point at which the motion returns. So velocity, what we are now going to find what is the velocity at extreme position. At extreme position, the point at which the motion returns. What will happen is v equals to omega a square minus a square. We have put x equals to a. We have put x equals to a amplitude, that is a maximum displacement. So what we get is here is 0. Okay, so velocity at maximum position. What is the velocity at extreme point? Velocity is 0. When the velocity, at what point the velocity is maximum? It is at mean position. And what is the velocity at the extreme point? The point from which the motion returns, 0. So this is what we understand with velocity. Next term that I'm going to discuss is acceleration. Okay, next I'm going to discuss is acceleration. So again, using the first principle, a equals to dy dt equals to d2x upon dt square. Okay, a equals to dv upon dt equals to d2x upon dt square. We just obtain velocity equals to a omega, okay, cos omega t plus phi. We just obtain this relationship. V equals to a omega cos omega t plus v equals to a omega cos omega t plus phi. Okay, a omega cos omega t plus phi. Now what we do is that we differentiate velocity equals to d by dt of a omega cos omega t plus phi. We differentiate it. We differentiate dt equals to a omega cos omega t plus phi. We differentiate this thing. So when we differentiate this thing, what we get is that a omega square will come out, a omega square will come out, and what is remaining is minus sine omega t plus phi. Okay, we have differentiated this thing, a omega. When again we differentiate it with respect to time, so omega will come, one omega will come outside. So what we have is a omega square minus omega sine omega t plus phi, or we can write is minus omega square a okay. So we can write now, we can write a equals to omega square minus omega square minus omega square a sine omega t plus phi. Okay, now but what we discussed earlier is x equals to a sine omega t plus phi. We discuss x or a sine omega t plus phi. Okay, earlier when we defined displacement, so the shift in the position. So what we have here, a equals to minus omega square a sine omega t plus phi. So what we can write for a sine omega t plus phi, this is x. So this is the definition of simple harmonic motion. Acceleration is directly proportional to negative of displacement, and what is the proportionality constant is omega square. And what is this omega? Angular frequency. Omega equals to angular free. Omega is angular frequency. Okay. So now we are going to discuss further on this relation, a equals to minus omega square x. This is simple harmonic motion. Okay, this is simple harmonic motion, a equals to minus omega square x. Let's write it down. Okay, a equals to dv upon dt. So a equals to minus omega square x, simple harmonic motion. So a equals to minus omega square x. Okay, a equals to minus omega square. So when x equals to 0, that is mean position. What is the acceleration at mean position? When x equals to 0 or mean, when x equals to 0 or mean position. So at that point a equals to 0. Okay, so acceleration is 0 at the mean position. Okay, acceleration is 0 at or x equals to a equals to, and when x equals to a, what happens? A equals to minus omega square a, maximum x. maximum acceleration is at the extreme point, okay, at the point from which the motion returns. So maximum acceleration at the extreme point, at the extreme point, maximum acceleration at the extreme point. So A equals to omega minus omega square x, and at mean position x equals to 0. Okay, so we have discussed simple harmonic motion, our acceleration direct proportional to negative displacement, and then we define displacement as x equals to a omega sin omega t plus 5. Then we define velocity. Velocity equals general definition, general equation of velocity, a equals to omega root under a square minus x square, and then acceleration a equals to minus omega square x. Okay, now we are going to discuss some questions. Okay, now I'm going to discuss some questions. Okay, first question that I'm going to discuss is a particle executing simple harmonic motion. A particle executing simple harmonic motion has an amplitude. Motion has an amplitude of 1 meter. It has an amplitude of 1 meter and time period equals to 1 meter, and time period of 2 seconds. The time period is given 2 seconds. So what we have to find is velocity and acceleration. We have to find velocity and acceleration. Find velocity and acceleration. Find velocity and acceleration at x equals to 0 point, or we can write as half meter. Okay, so this is the question. A particle executing simple harmonic motion has an amplitude of 1 meter and time period of 2 seconds. So we have to find velocity and acceleration at x equals to half meter, 0.5 meter, you could say. Okay, amplitude is given a equals to 1 meter and time period equals to 2 seconds. This is given, these data is given. Okay, so we have to find velocity and acceleration. Okay, so to find velocity and acceleration we need angular frequency. Okay, so time, what is angular frequency? Omega equals to 2 pi upon t. We discussed this earlier. Angular frequency is 2 pi upon time period. Okay, so 2 pi, what is 2 upon 2 seconds equals to, so first we find omega angular frequency equals to pi radian per second. Okay, omega equals to pi radian per second. Now we can find velocity and acceleration. I'm going to wrap the upper part of the question. equals to 2 seconds. Now, what is the definition of velocity? Velocity equals to omega a square minus x square. This is the omega velocity equals to omega a square minus x square. This is the general definition of velocity that we obtained just a few minutes before. Okay, omega is pi radian per second. Make substitution. Omega equals to pi. Okay, a is given as 1 square minus what is x at x equals to half meter minus half. So what we had is pi 3 upon 4 or pi upon 2 root 3. Numerical value comes out to be something like, okay, so velocity equals to pi by 2 root 3. Velocity equals to pi by 2 root 3. Okay, now we'll find what is acceleration. So acceleration, what is acceleration? Equals to minus omega square x. Okay, acceleration equals to minus omega square x. What is the value of omega we just obtained? Omega equals to pi radian per second and x equals to half meter. Okay, x equals to half meter. Okay, x equals to half meter. Now, so a equals to minus omega square minus pi square into half. This comes out to something of 4.93. Equals to minus meter per second square. So this is the value of acceleration that we get. A equals to minus 4.9 minus pi square upon 2, and we simplify it, calculate it, we get minus 4.93 meter per second square. So velocity was, this is velocity pi by 2 root 3, and this is in simplest term you could say this is minus pi square upon 2. Okay, now we are going to discuss another question. So second question is, in the above question, in the above question, find velocity, max velocity and acceleration max. You have to find maximum velocity. In the previous question, the data is for the same data, you have to find maximum velocity and maximum acceleration. What was the kind of dot information that in the question? A equals to 1 meter and t equals to 2 seconds. Okay, t equals to, so again omega equals to angular frequency equals to pi. Omega equals to 2 pi upon t equals to 2 pi upon pi radian per second. Okay, omega equals to pi radian per second. In the question, find V max and A max, and omega equals to pi radian per second. Now velocity max minus velocity max is omega into A. Maximum velocity omega into A when at x equals to 0. So this is maximum value velocity at x equals to 0 equals to, so pi into 1 equals to pi meter per second. So this is the maximum velocity. Maximum velocity that we get is velocity equals to pi into 1 meter per second. Okay. Pi into 1 meter per second. Now acceleration equals to minus omega square into a. Is amplitude. Maximum acceleration is at the point of amplitude. At that point, acceleration is maximum. So what we had, minus pi square into 1 minus pi square meter per second square. So this is maximum acceleration, minus pi square meter per minus pi square meter per second square. Okay. So same question. We have obtained maximum velocity, maximum acceleration, and maximum velocity. Now the next question is, a particle executing simple harmonic motion. Question is, a particle is executing simple harmonic motion of amplitude m equals to 10 centimeter. Given that amplitude is 10 centimeter and time period and the amplitude of 10 centimeter and speed equals to 5 centimeter. This is 5 centimeter per second at the speed equals to 5 centimeter per second at mean position. At mean, this is 5 centimeter per second at mean position. So at mean position, if speed equals to 5 centimeter per second at mean position, what it means that velocity is maximum at that position. Velocity is maximum at this position. Okay. Now we have to find calculate time period. Calculate time period. Okay. So what we have is that t equals to speed equals to maximum speed. So omega into a. This is maximum. A is 10 centimeter. When omega we have to find. So omega equals to omega into 10. Velocity equals to pi centimeter per. So omega equals to pi upon 10 radian per second. Omega equals to pi radian per second. Okay. This. So we have to find time. Now t equals to 2 pi by omega equals to 2 pi by omega pi upon 10. Pi cancel equals to 20 second. So omega equals to 20 second. Now next question. Particle question. Particle executing simple harmonic motion has its a particle is executing simple harmonic motion and acceleration is given as minus 4 pi square x. Okay, acceleration is given as a equals to minus 4 pi square x. We have to find time period. Okay, we have to find time period. A particle executing simple harmonic motion has acceleration equals to minus 4 pi square x. So we know that time period equals to 2 pi upon omega. And from this equation, what is the general equation of simple harmonic motion? E equals to minus omega square x. Okay. Now comparing coefficients, A equals to minus omega square x. This is the general equation of simple harmonic motion. Okay. Comparing coefficient. Comparing coefficients. Okay. Comparing coefficients, we get omega square equals to 4 pi square. Okay. We compare coefficients. We compare coefficients. We get omega square equals to 4 pi square, or omega equals to 2 pi. Omega equals to 2 pi radian per second. Okay. Omega equals to 2 pi radian per second. Now we substitute in this equation. T equals to 2 pi upon equals to 1 second. So this is the answer. We have particle executing simple harmonic motion, A equals to minus 4 pi square x. Time period is, we have to find out general equation of simple harmonic motion is A equals to minus omega square x. We compare coefficients. We get omega equals to 2 pi. We substitute and we get time equals to 1 second. Thank you.